everybody, my name is Uzefatu Abudu. Today I want to read a passage on how building design changed after 9/11. So pay attention and listen. Passage D. How building design changed after 9/11. When buildings fall and people die, it is a terrible tragedy. It is also a big engineering problem. In 1995, a building in Oklahoma City collapsed after a bomb exploded. In 2001, the World Trade Center towers collapsed after a terrorist attack. These events made engineers ask, how can we stop this from happening again? In Oklahoma City, a bomb exploded near a building. The building had 9 floors and was made of concrete. Only a few columns were broken, but that caused other parts of the building to fall too. This is called progressive collapse. It means when one part breaks, the rest of the building also falls down. In the Oklahoma City attack, 268 people died. A month later, the rest of the building was taken down on purpose. On September 11, 2001, two planes hit the World Trade Center towers. The heat from the fire made the steel columns weak. Other parts had to carry more weight and could not hold the loads. So the towers fell. Before these events, engineers did not think much about progressive collapse. Now, they know it is very dangerous. Today, engineers try to design stronger buildings and use better materials. In places with earthquakes, buildings must be flexible. This means they can bend without breaking. This is called ductility. Engineers want buildings to have high ductility to resist falling. Many building codes already require this for earthquakes. But explosions are different from earthquakes. So, buildings need special design to handle both. Another important idea is redundancy. This means using extra supports in case one part fails. If one column is broken by a bomb, the building still stands. There are not many rules about redundancy, but some groups like the National Institute of Building Sciences give helpful design types. In the World Trade Center towers, they still became weak from fire. But concrete stays strong even when it is hot. Concrete does not burn or melt. The new World Trade Center used very thick concrete walls and strong steel bars inside. These walls help keep the building standing even after a big explosion. Explosions put a lot of pressure on concrete. Normal concrete can hold about 3,000 to 6,000 psi, pounds per square inch. But new concrete used in one World Trade Center can hold 12,000 psi. Some new types of concrete can hold up 30,000 psi. This is possible because scientists make the particles in the concrete very small and tightly packed. To make concrete even better, engineers mix in tiny steel fibers. These are like very small needles. They stop cracks from spreading. This new material is called ultra-high performance fiber reinforced concrete. It is very strong and flexible. Tests show it is very good at resisting damage from explosions. In the future, more buildings will use this material to stay safe during attacks. Engineers today are using better designs and stronger materials. The goal is to make sure buildings stay standing even if there is an earthquake or an attack. These improvements will help save lives and protect people from future tragedies. Comprehension check. Task 1. Answer true or false. 1. Engineers were always very concerned about progressive collapse before 1995. False. 2. The World Trade Center towers collapsed because the heat weakened the steel. True. 3. Concrete becomes weak and melts in a fire just like steel. False. 4. Ductility means a building can bend without breaking. True. 5. Redundancy in construction means using more columns or support in case one fails. True. 6. Ultra-high performance fiber reinforced concrete is strong, flexible, and good at resisting explosion damage. True. Task 2. Choose the correct answer. 1. What material stays strong even in high heat? A. Steel, B. Glass, C. Concrete, D. Plastic. The answer is C. Concrete. 2. What does redundancy in building design mean? A. Using one large support to hold the entire structure. B. Designing buildings with multiple exits. C. Including extra support in case one fails. D. Avoiding the use of steel and concrete. The answer is C. Including extra support in case one fails. 3. What is the strength in PSI of normal concrete? A. 1000 to 2000 psi. B. 3000 to 6000 psi. C. 10,000 to 15,000 psi. D. Over 30,000 psi. The answer is B. 3000 to 6000 psi. 4. What improvement makes ultra-high performance concrete resist damage better? The answer is C. Tiny steel fibers mixed into it. 5. What is the main goal of modern engineers in designing buildings after these tragedies? A. To build tailored skyscrapers. B. To use less material. C. To make buildings look more attractive. D. To make buildings strong and safer in disasters. The answer is D. To make buildings strong and safer in disasters. I'm at the end of my reading section. Thank you for your attention and goodbye.